Hi everyone, welcome back to Chemistry 24x7 series. In this series, we have been exploring the solution for previous year competitive exam papers. If you are new here, don't forget to subscribe and hit the bell icon for notification. Let's see what's today's problem. So this is the problem from CSIR 2022. As per this question, so this alkene react with 9-ppn in the first step. In second step, which react with bromobenzene and palladium tetracase under potassium phosphate phase, which produce a product. So here there are four options are given. Let's solve together which one is the correct option for this question. In the first step of our reaction, so this alkene react with 9-ppn. So this is the structure of 9-ppn, so which is one of the sterically hindered organoborane. So in this reaction is particularly hydroboration reaction. So which means that this organoborane going to add across the double bond. So here there are two alkene are present. So one is here, another one is here. So next we should think about which alkene going to react with this organoborane. So now you closely look this 9-ppn structure, which is heavily sterically hindered organoborane. So therefore, which definitely prefer to react with less hindered alkene. So now you compare in these two alkenes. So which one is less sterically hindered one? So absolutely this terminal alkene is less sterically hindered. So this reaction usually undergo by syn addition. So which means that both hydrogen atom and boron atom along with this remaining species going to add same phase of alkene. And another important point, so this reaction usually undergo by anti-Markovnikov rule. So according to anti-Markovnikov rule, so hydrogen atom going to add this carbon in case of this boron atom, so along with this remaining species going to add terminal carbon. So resulting that generate this trialkyl borane intermediate. So this trialkyl borane intermediate in next step react with bromobenzene and palladium tetracase with potassium phosphate base. So once you see this condition, most of them get an idea about Suzuki cross-coupling reaction. Yes, this is a Suzuki cross-coupling reaction. So we have already discussed about Suzuki cross-coupling reaction and their catalytic cycle and magnetic details along with various solved problems. If anyone missed that video, you can find the link in the description box below. So let's moving to the our second step of this reaction. So in second step, so I already stated that this is a Suzuki cross-coupling reaction. So the first step of Suzuki cross-coupling reaction would be a generation of active palladium complex. So according to that, so this reaction requires palladium 0 catalysis. Therefore, the first step of the second step reaction is generation of palladium 0 catalysis. Once you generate the palladium 0, which readily undergo oxidative addition with this bromobenzene. So which produce this corresponding palladium complex. At the same time, our trialkyl borane, so this intermediate we obtained from the first step of this reaction, which readily react with potassium phosphate tribasic, so which generate this corresponding species. So here you should remember that Suzuki cross-coupling reaction requires base, since trialkyl borane would not undergo the transmetalation with this palladium complex in absence of base. So therefore base is necessary to activate this trialkyl boron in order to undergo transmetallation reaction. So now you see this species is now ready for transmetallation with this palladium complex, so which produce this corresponding palladium complex, so along with this byproduct. So now this palladium complex readily undergo reductive elimination in order to regenerate palladium 0 catalysis and produce this corresponding carbon-carbon coupling product. So let's moving to the our question. So as per our discussion, among the four answers, the correct option for this question is option 1. That's it for today's problem. I hope this video has helped you to understand this Suzuki cross-coupling reaction along with the selectivity of hydroboration reaction, the presence of two type of alkene. If you enjoyed this session, just give it a thumbs up and share it with your friends, and don't forget to subscribe ChemOrgChem for much more content like this. And finally, thanks for watching. Bye bye.